All right, let's talk about that little padlock you see in your browser's address bar. You know the one, we see it every day, but what is it actually doing? It's way more than just a tiny icon. So today, we're going to unlock its secrets. You've seen it a million times, right? When you're banking, shopping, or just scrolling through your feed. Well, that tiny symbol is your own personal digital bodyguard. It's actively working to protect your passwords, your credit card info, and your private messages. It's the sign that you're using something called HTTPS.
Now, to really get why this lock is such a big deal, we have to travel back in time to the early days of the web. It was kind of like the Wild West, and online communication had this one massive fundamental problem.
See, the original web ran on a system called HTTP. It changed the world for sure, but it had this one glaring vulnerability. Every single piece of data, we're talking usernames, passwords, everything, was sent as plain readable text.
Using an old HTTP website is exactly like sending a postcard. I mean, the mail carrier can read it, the person at the post office can read it, anyone who gets their hands on it can see your entire message. You wouldn't write your bank password on a postcard, would you? Of course not.
And that is where our hero, HTTPS, enters the chat. That S is the magic ingredient. It stands for secure. And it's the modern upgrade that fixes that whole postcard problem by adding one crucial layer of security. So, what's the big difference? Honestly, it all boils down to this. With HTTP, your data is plain text, just an open book for anyone to read. But with HTTPS, that same data is encrypted, meaning it's all scrambled up into unreadable code.
So instead of a postcard, HTTPS puts your message inside a locked steel safe. Now, even if someone manages to intercept it on its journey, all they have is a box they can't open. Only the website you're actually talking to has the special key to unlock it.
So how does this digital safe get built? It's not magic, even though it feels like it. It's actually a really clever, super fast process that happens every single time you visit a secure site. Let's break it down.
It's all thanks to something called the SSL/TLS handshake. Now, SSL is kind of the original gangster, but today we almost always use its newer, stronger cousin, TLS. Think of it like a secret handshake between your browser and the website to make sure they can trust each other before they start sharing secrets.
And this all happens in the blink of an eye. So you type in a website, your browser basically says, hey, prove you are who you say you are. The website responds by showing its digital ID card, called a certificate. Your browser then checks to make sure that ID is legit and not expired. Once it all checks out, bam! The secure connection is made and that little lock icon pops up.
That SSL certificate is the key to the whole thing. It's like the website's passport. It does two critical jobs. First, it proves the website is the real deal, not an imposter. And second, it contains the public key that's needed to start scrambling the data.
So who hands out these digital passports? They come from highly trusted organizations called certificate authorities. You can think of them as the DMV of the internet. Their entire job is to verify that a website is legitimate before they issue a certificate, which creates this whole web of trust.
Okay, so this whole system of trust is really built on three powerful pillars. These are the superpowers that work together to keep you safe online. Let's look at exactly what HTTPS protects.
First up, the most famous one, encryption. This is the art of scrambling your data so it looks like complete gibberish. So if a hacker is snooping on the coffee shop's Wi-Fi, they don't see your password. They just see a meaningless jumble of characters, totally useless to them.
Second is authentication. Thanks to that certificate we talked about, HTTPS guarantees you're connected to the real server. This is what protects you from those fake imposter websites that look just like your bank but are designed to steal your login info. And the third pillar is data integrity. This ensures that the data you send is the exact same data that's received. It prevents an attacker from, say, intercepting your bank transfer and secretly changing the destination account number without you ever knowing it happened.
So we've covered the what and the how. Now let's bring it all back home. Why does this actually matter in your day-to-day life?
What's absolutely essential pretty much everywhere you share sensitive info. I'm talking online banking, shopping with your credit card, sliding into DMs on social media, reading your private emails, or using government portals. All of these rely on HTTPS to keep your private life, well, private.
And without it, yikes, the risks are huge. Your passwords can be swiped, financial details can be intercepted, and your data can even be manipulated. It's gotten so serious that modern browsers will now basically scream at you with a big not secure warning if a site isn't using HTTPS.
But, and this is a really important but, is HTTPS a magic shield that makes you totally invincible online? The honest answer is no. No single system is 100% hack-proof.
See, HTTPS is brilliant at protecting your data in transit while it's traveling the internet. But it can't protect you if your computer itself is infected with malware. It can't stop you from getting tricked by a really clever phishing email. And it certainly can't help you if your password is password123. Security is all about layers.
So, the best way to think about it is this. HTTPS creates a secure, private tunnel between your device and the website you're visiting. It's protecting your data on this journey across the wild, open internet. And now, next time you see that little lock, you'll know exactly what it's doing for you.
And that leaves us with one final, crucial question. The lock does its job protecting your data as it travels, but once that data arrives safely on your computer or your phone, whose job is it to protect it then? Something to think about.